Alright, so for 38 through 44, you're going to be writing an equation in vertex form. I know the book says standard, but we're using vertex form, given the point and the vertex of the parabola. So for 38, they gave you a picture, the graph of the parabola, but they also labeled the points. So I know that vertex is -2, -1, and another point on the line is 0, 3. So we start off by writing the equation, and then we substitute the value. So f of x is y, and so I also know that this is my h and this is my k, this is my x and this is my y. So this is how I'm going to substitute into the equation here on the right. So y is 3, x is 0, minus a -2 squared, don't forget the squared, minus 1, because k is -1. Okay, so again, we know that because of that, we saw the picture, right? So the parabola is opening up, so we're expecting a positive a value. So right here we get plus 2, and when we square it, it's 4a, or 4. And so it's 4a minus 1. Do not subtract the 1 from the 4. Okay? This one right here, we're going to add to both sides. So 4 is 4a, so a is 1. So then our equation would be f of x equals, you don't have to write it, when a equals 1, you don't write anything, because it's assumed, and it's plus 2 squared minus 1. So here's the equation in vertex form. Okay, so number 40, same setup as number 38. You have the vertex, you have a point on the graph, and then I just wrote the equations on the right there. So all we're going to do now is substitute. So this is my x and my y, this is my h and my k. So for y, I'm going to put in -7. For x is 6, for h is 4, and then plus 1, because k is 1. So right here I get a 2, and so that's, when you square it, you get 4. So if you tend to want to combine the 1 here with the number here, if you find yourself trying to do that, let's avoid that by subtracting the 1 first. We could do that, that's perfectly okay. So then you have this. And so I have 2 squared, so that's a 4, so divide by 4. So a is -2. Okay, now did we expect a negative for a? Let's see, the vertex is 4, 1, and another point on the line is 6, -7. So yeah, we expected the parabola to go down, open down. So your function is f of x equals -2 x minus 4 squared plus 1. Alright, so 42, I've got the setup with the equations and everything. Here's x, here's y, here's h, and here's k. So now all I have to do is substitute. So for y, I'm going to put in a 4. For x, I'm going to put in a -2. For h, I'm going to put in a -4. For k, I'm going to put in a -1. So again, like I said in the other one, if you want, you can add the 1 right now. That way you're not in danger of combining it with this number here and getting it wrong. So let's get it out of the way. So you have 5. And right here, 4 minus 2 is 2. 2 squared is 4. So 4a. So I'm dividing by 4. So a is 5 over 4. Okay, and again, is that what you expected? Let's see. The vertex is -4, -1. That's a vertex right there. And -2, 4, that's a point. So yeah, we expected a positive a. Okay, so you write your equation, f of x equals 5 over 4 x plus 4 squared minus 1. Alright, so 44 has some fractions. No biggie, no big deal. Let's just go ahead and do the substitution. So I've already labeled hk and xy. So for y I put negative 17 over 16. Oops, a we don't know. X is 0. H is negative 1/4. We're going to square it, and then k is negative 1. So let's move the 1 over right away. So this 1 is actually 16/16, so you end up with negative 1 over 16 right here on this side. And then right here, this is 1/4, but when you square it, it's 1/16. So it's a over 16, right, because it's 1/16 times a. So I'm going to multiply by 16 on both sides. So negative 1. Now, is that what you expect? Let's see, the vertex is at negative 1/4, negative 1, so about here. And the y-intercept, I'm sorry, well, it is a y-intercept, 0, negative 1 and 1/16, so it's a little bit lower, like right here. So yeah, we're expecting the graph to open down. So you write f of x equals negative, you don't have to put the 1 in, so x plus 1/4 squared minus 1. Alright, so for 46 through 54, they want you to find the x-intercepts. They want you to find it visually and then algebraically. So just by looking at it, it looks like the graph crosses the x-axis at around a number less than 1, so between 0 and 1, and then again at negative 3. Okay, so let's go ahead and do the work algebraically. So what, So what I'm going to do is see if it factors first. So negative 6x squared. Factors of negative 6 that add up to 5 are 6x and negative x. Okay, so it does factor. I do the box method, you do whichever you prefer. 2x squared, 6x, negative x, and negative 3. Greatest common factor right here in this row is 2x. And then something here times 2x gives me 2x squared, so that would be x. And then something times 2x is going to give me 6x, so that's 3. And then finally, for this spot right here, something times x gives me negative x, and that would be negative 1. And then just as a last check, I do 3 times negative 1. Does that give me negative 3? The answer is yes, so my factoring is correct. So my two factors are 2x minus 1, I get that from here, and x plus 3, I get that from up here. So my x-intercepts are 1/2, 0, and negative 3, 0. So by looking at the graph, it looks like it intersects somewhere between 2 and 3, or maybe on 3 on the x-axis. So to do the work algebraically, I noticed that this is a square number and the square root is 3. When I double 3, I get 6. So then that tells me that this is a perfect square trinomial that factors like this. Why the negative in between the x and the 3? Because this is a negative right here. So this sign just drops. Okay, so from here, I know that the the intercept, which happens to be the vertex, is 3, 0. Okay. Okay, so that's the x-intercept, 3, 0. Alright, so for this one, I'm just going to continue finding the x-intercepts algebraically. You could input these equations on Desmos or on your own graphing calculator just to verify your answers. But again, I'm just going to use the algebraic method. So what can you factor out of these two? So I can factor out a negative 2x. And when you do that, you get x minus 5. And so my x-intercepts are 0, 0, because this here is a 0, and 5, 0. Oops, I forgot the and. So those two right there. Alright, so this, again, I'm going to approach this with the algebraic method. So I'm going to multiply these two and get negative 84x squared. Factors of negative 84 that add up to 25 are negative 3 and 28. Okay, so then, and I could just use the coefficients. I don't have to use the x because I know at the end I'm going to add the x. Okay, so I'm just going to use the coefficients and the constant. So greatest common factor in this row is 1. 1 times 4 is 4. 1 times negative 3 is negative 3. And then for this section right here, 4 times something gives you 28. And that's 7. And then just as a double check, is negative 3 times 7 negative 21? Yes, so your answer, you're done. So your factors are x plus 7. You get that from here. And then 4x minus 3, you get that from here. So the x-intercepts are negative 7, 0. And then again, you set each one equal to 0, each factor. So like if you have a coefficient like you do here, you set this equal to 0. And so you end up with 3 over 4, 0. So again, if you don't get that, remember you're setting this equal to 0 and you're solving for x. So you move 3 over and then you divide by 4. And you get 3/4. So for this problem, I'm going to just leave the 7/10 out and just focus in on this and factor that. So factors of negative 45 that add up to positive 12 are negative 3 and 15. So this becomes y equals 7/10 x minus 3, x plus 15. So my x-intercepts are 3, 0, and negative 15, 0. That's a 3. Alright, so for number 67, you have a